สวัสดีทุกคนค่ะสวัสดีค่ะสวัสดีทุกท่านที่อยู่ออนไซต์นะคะแล้วก็ทุกท่านที่อยู่ออนไลน์นะคะอันนี้เป็นวันที่3แล้วของการเลคเชอร์นะคะ Welcome everyone Welcome to the third day of the IAEA Expert Mission we are halfway through and we learn a lot from past 2 days we know about how we establish how the ACR established the DIR and things and Dr. Kalpana Kanel talking about the future for the DRL, right? And today we are going to talk about how to use the dose monitoring software to analyze radiation dose with Dr. Samuel Bradley. Welcome, Sam. Hope you enjoy yesterday. Have a good sleep last night. Enjoy food. Enjoy Bangkok, and ready for the lecture.
All right, thank you, Tanya. All right, so we've largely been talking about the dose registry. And so dose registry operates at a higher level. We send the data up, they analyze it for us, they send you back a report, and we know that DRLs are thresholds at which we can use as an investigation tool. If we're below the DRL, maybe we'll focus on image quality investigation instead of dose investigation. And if it's above the DRL, then maybe we need to bring the doses down. So the question is, how do we know how to move those doses? And so when you have a dose monitoring software at your hospital, when you have a dose monitoring software at your hospital, you have the ability to really kind of dig into the detail and start to find where the trends are and how to lower the dose. And so what we're going to talk about today, Dr. Canal and myself, is we're going to talk about dose monitoring software. We're going to give, first I'm going to talk a little bit generally, just about kind of what to look for when you are choosing a dose monitoring software. And then we're going to each give some examples from our systems, and then you can use that as kind of a learning tool as you apply, because I'm sure everyone has their own dose monitoring software. All right, so we talked about, I've shown you this slide a couple times now, how there's actually quite a few options. And so the question is what to buy and what to look for. And if you go out on the market, there's about 18 or so, maybe a few more that I'm just unaware of as of the last year or so. We know we've talked here with the Thai group, the majority of the people operating within the dose registry system are using Radometrics. And this morning, actually, we reviewed the Radometric data for for several of the hospitals that have been submitting. Obviously, there are other options. I know Pax Health is also something that's been listed, has been mentioned, that is here in Thailand. So all of these have pros and cons. We're going to talk a little bit about some of the things that you need to look for when you go to purchase your dose monitoring software. And I did mention that there are some open source ones, and they are great because, for example, this OpenREM, you can go on and you can download it. It was written using Python, and Python is open source, and so all you have to do is download it, and you can use anything you want. You can use it however you want. The website, I was going to bring this up. Sorry, I meant to have this already up. See right here. So you can go in here and, for example, this is free of charge, and they're constantly updating it. Oh, let me get rid of that. There we go. Thank you. All right, so you can go to their website, and you can actually, if you're really interested, you could actually contribute to it. And so if you see things that aren't great, you can actually help them write code to improve it. Not that you want to do that, but my point is it's open source, and so you know exactly what's going on when you use this. And it's good because it has CT, X-ray, fluoroscopy, mammography, and you can do all kinds of things that you normally would with Radometrics, Pax Health, anything. But like I mentioned, it's free. And so if you're curious as how to use this, or if you don't have the funding to buy one of the other systems, then that's a great option to start with, is looking at these these open source ones over here. All right. So when you go to look and to make a decision as to which dose monitoring software you want to purchase, you need to ask yourself which modalities does the software cover. And we know basically all of them that I showed on this previous slide, basically all of these, they all cover CT. That's usually a given. But then the amount of other modalities kind of falls off when you look at the different software options. So the next most common one is X-ray and fluoro, and 80% of the list I showed you previously can support those and would be great, especially when you're doing dose registry for more than just CT. But then nuclear medicine is one that is not as common, and so only 60% do it. MRI and ultrasound, those aren't for dose, obviously. That is for usage and utilization. And so we personally started using MRI with our Radiometrics, but we opted to not use it because you can do usage. You can calculate usage a different way. And so it was just slowing down our Radiometrics, and we didn't use it. We didn't want to do MRI usage anymore. So when you go to install your dose monitoring software, the various different vendors have options as to how you actually physically install it at your hospital. Some will do a physical server where you have to then buy and constantly maintain it. So every 2 to 3 years, depending on your hospital, maybe more, you would physically have to change the actual server, the computer system. Some of them will allow you to do what's called virtual machine. And so in this case, you'll have a certain amount of servers already at the hospital. And then what you do is basically just you'll just take a certain allocation from each of these servers, and your IT specialists are able to help you do that. And so this is nice because you don't necessarily have to have a dedicated server. You can just use the extra space on different servers, and it all comes together. And then in other situations, you can do what's called cloud computing, where you actually don't physically have to purchase the server. That server's maintained somewhere off-site. Your software is there, and you never have to worry about it. They will maintain the hardware. Everything is taken care of. You would just log in through the web, and you would be able to do all your work on that dose monitoring software virtually. All right, so when you're going to make a decision of to which dose monitoring software to purchase, you need to ask yourselves a few questions. So the first question is, where does the dose report come from when it is imported into the dose monitoring software? Does it come from PACS, or does it directly come from the scanner? There's a couple of, we have personally, as I've mentioned, we have a couple of different dose monitoring software options. And one of ours, our Radiometrics, it directly comes from the scanner. So after the scan is done, we've already set it up so that there is a send node. And so when the technologist completes the scan, it automatically sends to PACS, and it auto sends to Radiometrics. And we don't have to think about it. The only problem with that is if you change the scanner, or if you buy new scanners, you have to make sure you set it up, or nothing will go to the Radiometrics. We have a second dose monitoring software called Dose and Care, and that one operates from PACS. So at the end of the study, when the technologist hits complete, the study goes to PACS, and the dose report goes to PACS. Everything just goes to PACS. And then our Dose and Care software operates in the background, and it's constantly looking at PACS, and it updates every couple of seconds. And when it sees a new study come through, it pulls the dose data off, and it then adds it to the dose monitoring software database. So we don't have to think about it. So every time we install a new machine, all we have to do is make sure it goes to PACS, which of course it has to, so that the images can be read in the reading room. So where the dose monitoring software gets its data is important, because some are more user intense, and you have to interact with it more than others. All right, so how does the software receive the dose information? We've talked about here several different ways. There's what's called the structured dose report, or RDSR, or there's usually kind of that image of the dose. It's a DICOM image. It's quite literally just an image. Some of the older scanners still use it. And so some softwares, dose monitoring softwares, cannot accept just the image dose report, the DICOM dose report, because they don't have the OCR, the optical character recognition software to read it. And so they only accept RDSR. And so that means that certain dose monitoring softwares will only accept older newer scanners. And also, you have to ask the system, the manufacturer of that software, does it collect and store the RDSR, or does it delete that? And some of them we've used some in the past where it collects it indefinitely in the background, and so the database gets bigger and bigger and bigger over time. Whereas once it's usually the newer ones, they'll get the radiation dose, the RDSR in, they'll read through the RDSR, take everything out of it, and delete it. And so if there's ever a correction that needs to make, you have to go in and manually correct it. So how they handle the data after it's been sent to the dose monitoring software is an important thing for you to consider. All right, what dose estimates are provided? And we'll talk a little bit more about that. There we go. Does it account for patient size? In other words, is it just age, or is it weight? Is it BMI? Does it do water equivalent diameter? And those are all important, especially when you're dealing with pediatrics. How does the software handle combo scans? Some softwares on the market, when you send say there's not a two-phase, but you actually have a scan with an add-on. So let's say you start with a routine brain and then they add a CTA on, or vice versa. There are some softwares out there where they'll take the two and they'll average them together. And so it's one exam with a very high CTDI number, when in reality it was one exam with it was technically two studies that were just put together. So you need to know how they handle multiple exams under one accession number. And then can the software do other fancy calculations such as fetal dose calculation, organ dose calculations, etc. Now, every software needs to be able to handle the unique aspects of the different imaging modalities. As I mentioned, all systems are good at handling CT, but they're a little less capable when you start to look at all the different modalities. And we know each modality has unique dose metrics. We've, of course, been focusing on CT this whole week, but obviously it's important to be able to do fluoroscopy and X-ray, especially if you're trying to do a dose registry beyond just CT. And so how does it take in all of these? Does it accept all of the different dose metrics? And does it try to combine them? How does it handle those different values and calculate patient dose? So we'll talk a little about that in a second, but we know from the physics world that CAP and DAP or air kerma, they're not equivalent to DLP or CTDI vol. And so there has to be conversion factors and corrections to be made. And so you can't necessarily combine CT doses with fluoroscopy doses without some mathematics in the background. So you need to ask the dose monitoring software vendor how they handle multiple modalities. All right, probably one of the most important things in my opinion is obviously once you know how it handles the data, how it imports and how it collates it, and how the next most important question is how does it display the data? We have, as I mentioned, we have several different dose monitoring. One system, it does not, that's all it does is you can see here kind of this small screen capture. All it shows is just a list of the exams and the list of the CTDI values. There's no plots, there's no scatter plots, there's nothing that you can do. It's not interactive. It just collects it and shows it to you. And so that's fine, but if you want to do any kind of deep analysis, most likely you'll have to download this to an Excel spreadsheet and do it manually. Whereas some of the newer softwares out there, they're very interactive. And you can click on data, you can look at it, you can drill down. So you can look at a CT head protocol, you can see how it trends as a function of different scanners, different ages, just however you want to do it. You can look at all kinds of different plots, and we'll talk about that in a little bit. So the way you analyze data is very important as to which software you pick. Some of them are more flexible than others. All right, so one of the ways you can do this is, as I've recommended in the past, if you're looking at 2 or 3 different options, you're going to demo the option. And so when you sit down with one of their salespeople, one of their application specialists, ask for a demo. And what you do is you want to give them a specific task. For example, you could say, what is the average head CT dose for a 3 to 5 year old? And then ask them to figure that out. And then what I would recommend you do is you pull out a stopwatch and time them. Because some softwares, it takes a lot of clicks to get those answers. Or others, it might just be 1, 2, 3, and you're done. And so that's actually important, right? If you are constantly trying to use this, so you got your DRL values, you got your report back, and you find that, oh, my head doses are a little high. I want to lower them. Well, how do you understand where the problem is? And that's where the dose monitoring software is going to help. And if it takes a long time to figure that out, it can be very frustrating. So, all right, so some softwares are not as user-friendly. All right, what about dose notification? One of the beautiful things about dose monitoring software is that it can actually alert you. So you don't necessarily have to use the software every minute of the day, but you can set it up so that when a scan happens in the clinic, and then it goes to the dose monitoring software and it realizes, oh, this exceeds a threshold, then it will send out an email alert or something, and it'll notify someone that some scans have been overdosed. And then, or oh, they have exceeded the threshold is really what it says. And then you can then start to investigate. So you need to ask the question, how are outliers identified? And then what kind of reports are generated? How do you receive alerts? Is the output customizable? In other words, is it just one email to a manager? Can it send multiple emails to different people? Or do you actually have to log into the software to see that the alert happened? And so there's all kinds of options for the different types of alerts that happen. And then when you look at it, when you look at all the options out there, pretty much all of them will offer you email and the ability to download those types of data. But when you look at this, now there's about 10% of them or less will actually show those alerts on the dashboards. And so et cetera, et cetera, et cetera, you can just kind of look at how they handle alerting. There are other actual additional features that I have found to be pretty interesting as I've talked and worked with my colleagues in this field. For example, Dosewatch and Dose Monitor, they can actually track image quality voting. And so if you set it up on the PACS system and the radiologist reads the image, and most PACS systems can allow a field where they can select either good quality, bad quality, or they can even leave a comment. These two softwares will actually collect that information. So not only do you get the dose information, but you can also get kind of a score that this was good, bad, or ugly. And then you can use that to associate image quality with the radiation dose. Melogix offers protocol mapping and protocol optimization support, which is really big if you're trying to use it for dose reporting. And then Radiometrics and Sectra, they integrate into the voice reporting, which for us in the US is actually an important thing. Some of the states in the US require that the dose report as listed on the exam is placed into the radiologist report. And so instead of the radiologist needing to read it and dictate it, the Radiometrics or Sectra can actually just simply append it to the radiologist report, and they don't even have to think about it. All right. And then obviously, if you're looking, just ask for what else can my software do? Does it only do dose monitoring, or can I do more? And a lot of the newer softwares are actually incorporating a lot of different options. The Dose and Care that I referred to that we're looking at actually does a lot where it integrates with the RIS, the HIS system, and we can actually make comments and stuff, and that'll store comments. You know, for example, we might find that a patient was pregnant. We can put that into our system, and then that can communicate back via HL7 feeds to the HIS system. And so you can actually get information in and out into patient records. So it's actually a pretty interesting feature. The softwares are really evolving to be more than just simply showing dose data. All right, so where do these the dose monitoring softwares really, where are they the strongest? They are great when you're trying to do internal audits. And we actually did a exercise this morning where we were looking into some data and we were trying to figure out why certain exams were maybe a little higher in dose than others. Excuse me. And so that's where dose monitoring software is just great, because it collects all that data and it puts it right in front of you, instead of you needing to necessarily walk to the scanner and then walk to the next scanner and try to figure out why that one's different. It allows you to query individual cases, query doses by protocol, and it's great for protocol optimization. So I very much love using dose monitoring software to try to figure out which protocols really need tweaking, and where I can make those changes. And I can make that game plan. I can figure out what I want to do before I even walk over to the scanner. Some of the weaknesses for dose monitoring softwares is tracking patient exposure history. A lot of people want these dose monitoring softwares to give us dose to the patient so we can do some kind of risk assessment. And the reality is once again, most, if not all, of these dose monitoring softwares are not able to give you patient-specific dose. And we'll explain that in a minute, but obviously, as just a quick example, we know CTDI-vol for CT is not patient dose. And so it collects that data because it came off the scanner, so we can't necessarily then say, well, this is the patient dose. And that can be kind of scary because it'll list it, patient name, exam dose, and now we just say, oh, this is patient X, Y, and Z's dose. There's some softwares out there that will, actually a lot of them, provide what's called accumulated dose reports. In other words, they will allow you to set a threshold that if a patient receives a certain level of radiation over a certain number of studies, that it'll send a warning. And now this is something that's very controversial, and personally, I don't like that. We talked about that on our very first study, first day, how dose given instantaneously has a higher risk, and dose spread out over time has a lower risk, because the body has a chance to heal itself from the radiation effects from those exposure events. And so to accumulate dose and to say patient XYZ got a certain dose, doesn't explain the difference in time points. And it doesn't necessarily say that, oh, maybe there was a 2-3 year difference between those exposures. And if one patient gets a CT scan today and he gets a CT scan 3 years later, we shouldn't necessarily look at the risk as accumulated. We shouldn't say, oh, this person, now he's got a second scan 2 years or 3 years later, has twice the risk. That's just not how risk is calculated. So the softwares that accumulate that dose, we have to be very careful how we do that. Personally, my softwares do that. I don't even look at those reports because they just don't mean anything to me. And then, here we go, patient dose calculations. Most of them will take in the information and will allow you to do some kind of higher level dose patient-specific dose calculation using Monte Carlo. But the way they do that is unique and different to each software. Some of them still use these old mathematical stylized phantoms, which are good, but this is not obviously a human being. So it's a little less patient-specific. And then there's these newer versions of voxelized or these mesh type phantoms that they look a little bit more anthropomorphic, more human-like. And so when we apply the CTDI-vol and do the dose calculations on these, the dose is a lot better estimate to what the patient actually received, as long as the patient looks and is of the same size as this phantom. So you need to ask them what kind of phantom they use for the dose calculations and how many options they have. If they only have, say, 2 phantom options, male and female adult, well, that's fine as long as your patients all look and are the exact same size as those phantoms. And you couldn't even use them for pediatrics. Most of the newer softwares have a very large library of phantoms, so little kids up to big adults, and they'll different body sizes, obese to very thin. So you want to just ask them what their options are and how they do the dose calculations. And from these calculations of applying the CT dose metrics applied to Monte Carlo on these phantoms, we can then start to calculate effective dose. And that's okay. Once again, we know effective dose isn't patient specific, but almost always when we read in the literature, and we've talked about this over the week, over the last couple of days, is when we try to compare outputs for a patient population, radiation outputs for a patient population for various different modalities, say CT to X-ray to fluoro, we almost always convert the value to effective dose. Because going back a couple of slides, I showed you how all the dose metrics are different for each imaging, for each modality. And CTDI evolve is not equivalent to CAP, and CAP is not equivalent to air, et cetera. And so it's important, and so in that case, using, being able to calculate effective dose using your dose monitoring software is great, because then you can look at the effect of dose across multiple modalities for a specific patient. Most of the softwares, the way they calculate dose using Monte Carlo or doing effective dose is somewhat of a, I call it a black box. In other words, they don't tell you how they do it. And so you should ask them, and you should be skeptical, because are the doses that you're calculating on this phantom the same with one dose monitoring software as another? Because if they're not, then the values you're collecting at your hospital may not translate to something that another hospital could understand. All right, and then there's different, I've already mentioned this, you need to ask them how they handle combo cases. Because like I said, some softwares out there will actually weight the CTDI. So say you have 2 or 3 series, they'll take the CTDIs of each of those series and they'll do a weighting. And so instead of showing you the 3 individual CTDIs, they'll give you only one value, and that value may be a little higher or lower than what's listed. And so it's not quite appropriate in that regard. And the other thing is, if you have, say, 2 scans under one accession number, then oftentimes they'll just combine them, and it'll just be a very high number. So you need to ask them how they handle those very unique cases. So we're talking CT, of course, so what predictor should we make sure these dose monitoring systems have or can handle? Obviously, we want to make sure they can handle CTDI volume, which is a really good metric for helping to optimize scan protocols and being able to change parameters, to change parameters and to set alerts. DLP, we've also talked about that. It's not only just the output from the scanner, but it's the output as a function of the distance you scan on the patient. So it's really good to calculate kind of the more of a risk assessment of the total energy imparted to the body. And then SSDE, I would make sure all your dose monitoring softwares can calculate SSDE, because that helps scale CTDI volume for the patient size, and it gives you a better approximation for what the actual patient received dose-wise than just looking at the volume CTDI. Effective dose, as I've mentioned, is not patient-specific, and it should not be used for setting alert levels, but it is a really good way to compare from one modality to another. And then organ dose, it's great if all of your dose monitoring softwares can provide some kind of organ dose. And that requires that specialized Monte Carlo software that comes with it. And I oftentimes use this when I'm trying to figure out when I go to optimize my doses and my protocols, I'll usually run a couple of simulations using the Monte Carlo software just to see how it affects the doses across various different organ bases. So you don't necessarily use organ doses for dose registry. We're never going to be sending those up to OAP to do any kind of DRL settings. We just don't use organ doses for DRLs. But when you look at optimization, organ doses are really good. And so it's important to ask to make sure that they can do that. All right, so I've mentioned setting up alerts. You want to make sure that your dose monitoring software can set up alerts, and this will be helpful when you sit down and you work with your dose monitoring committee to optimize your image quality. And so obviously we've talked about who should be a part of that dose committee. I personally, at least in our hospital, we meet quarterly and we just review the alerts that we get off of our software. And so not only are we looking at trying to figure out why certain protocols are higher than DRLs, we'll also look at the list and we'll say, okay, so for this quarter we had, say, 10 studies and they exceeded these thresholds. And then we look at it and we say, well, what went wrong with these 10 studies? And inevitably it was someone just selected something wrong protocol. So instead of selecting a brain with contrast, they picked CTA accidentally, or non-contrast and they pick CTA accidentally. So it's usually just mistakes that we can then go back and do education. The thing I would mention though is you have to be careful when you set these thresholds. We initially went in and we set up our software and we didn't realize that the thresholds had actually been set real low. And so every time we got a study, and we were getting quite a few studies that were exceeding our alert level. And so we were getting email after email after email. So you need to make sure you set your threshold at an appropriate level. I'll talk about that in a couple slides, but just verbally what I could say is we set all of our alert levels at 99%. So only 1% of our protocol, 1% of our exposure events will actually set an alert. And I'll show that in a minute. Now, this is very important. I want to just make sure that we're very clear here. Setting alerts on the dose monitoring software is great for protocol review. You still need to make sure that you have dose alerts set on the scanner itself. And that's the best way to catch the mistake before it ever happens and we accidentally overexpose our patients. So every system, it's been established based on NEMA standards that every system must have some kind of dose alerting. The first level is what we call a notification value. And what's going to happen here is you'll have your protocol set up and it'll have an anticipated CTDI value. And then you'll have a threshold that you'll set. And so the system expects a certain output for, say, a brain with or a brain without. And if someone accidentally changes a feature, say they change KV or they change the MA or they do something, and they didn't mean to, but they just do it, and that changes the dose on the back end, when they hit go, the screen will pop up and it'll say, whoa, I was expecting a dose at a certain level, and whatever features whatever technique factors you've now accepted, I'm going to get a different dose level. So it's just warning you that something has changed, and it gives you a chance to hit edit and go back and fix it. Now, there's occasionally when you did that on purpose, and it's almost always because maybe a patient shows up and they're just larger than expected, or they can't lay perfectly supine. Maybe they're in a contorted position, or their arm has to be down to their side. And so you say, I know I need a little bit more radiation dose, so you manually change that. Then you would simply say in this case, oh, I know it's going to be higher, so I tell them the reason. This is an example. You can say patient is large, and you hit OK, and the scan proceeds fine. And that's exactly what I just said. And then the other option is what's called alert values. And this is, Dr. Canal showed you this example of this poor little boy. He went in and they were doing a scan. He was scanned 151 times for 65 minutes. And that's why he had the erythema right here along his face. And so what ended up happening is they wanted to set a second level to prevent something to happen like this. And this is where it will, for every scan, every time the machine goes and turns on, it's accumulating a CTDI value. And if you scan it multiple times, 10, 20, 30, up to 151 times, you're eventually going to exceed a value that you can set as a threshold. And this prevents overexposure events from serial scanning. So you can think of like a perfusion study or something where your system is constantly turning on and going and going and going and going, because it's usually waiting for contrast bolus to arrive. When you exceed a threshold, and when you're talking about alert values, that same window will pop up. But this time, instead of it saying, tell me why you want to keep using dose, you'll make that adjustment. You'll also have to enter in a password. And so basically this requires someone to get higher level permission to keep scanning. And this is meant, as I mentioned, to simply just prevent an event like this. Now, I would point out that all of your modern scanners are going to have this feature, but I would argue most people have probably never changed the value that came preset on the system. And most systems come with a preset of about 1,000 milligray. So you have to ask yourself, is 1,000 milligray as a cumulative dose a sufficiently low, or is it too high of a threshold to prevent an accident like this to happen? So you need to set your notification values, and you'll do that for each protocol that you have on your scanner, and you'll have to set your alert values only once, and that's just that upper threshold. And so, like I said, usually the default is 1,000, but you might want to actually lower it. That's just to be more sensitive, and so you don't actually overscan someone. All right, so that's just kind of a general broad discussion of different dose monitoring softwares, all the different features that come with them, things that you should really kind of put in the back of your head when you're trying to decide, do I want one product or one vendor versus another? So now I mentioned that we personally have Radiometrics, we have Dose and Care, and we have PEMNet. Our PEMNet's older and it's being phased out, and so we've brought in Gurbei's Dose and Care, and we were investigating that. I'm not going to necessarily talk a lot about Radiometrics because here in Thailand, you guys have it. And as we were watching this morning, we had great experts that know exactly how to use Radiometrics, and they do it very proficiently. So I thought I would just show you some other things that we do using a different software. So why did we change and go to and start looking at Gurbei? So as I mentioned, Gurbei pulls all of our structured dose reports or the DICOM images, just the DICOM dose screen captures. It pulls it from PACS. And for us, that's actually very helpful because we constantly have changing equipment in our hospital, and all we wanted to do is make sure, and every time something would change and we didn't know about it, then we would show up and we would just all of a sudden realize after a couple of weeks, couple of months, or every quarter, all of a sudden we just had missing data. And so having it go straight to PACS and then from PACS go to our dose monitoring was a big thing for us. We really like it because it interfaces with all imaging modalities. So everything from nukes to CT, X-ray, fluoro, mammo, even though we don't do mammo at children's hospitals, everything and anything goes into it, and we really like that. And additionally, it interfaces with our risk system. So every day we have it set up that it displays the list of the patients scheduled for the day. And that is really, we use that for our IR and our cath lab. We have our morning huddle. And what they can do is they'll just simply look at it and they have, okay, here's our, 10 patients, 20 patients for the day. And they can just go through and quickly look at it. And they could, if they wanted to, then pick and select each one of them. And it'll show you the dose map, the skin map. And so if they did a procedure a couple months ago or a couple weeks ago, whenever, they will see the total skin dose, and they'll show them which angles and all the different positions that and how the dose was distributed over the skin. And so we encourage our interventionalists to look at that, and that helps them in case they say, oh, this patient's had a lot of dose over the last couple of weeks or months. Maybe we should plan to come in at a different angle. And it just helps them to understand. So when they walk in to start using fluoroscopy, they already kind of know in the back of their head how much the patient's skin has received. So they don't have to worry about skin effects later on. Anyway, and it also interfaces with the radiopharmaceutical database. So it's nice because the way we do our dose calculations in nuclear medicine, everything is entered into a radiopharmaceutical database. All of our technetium doses, FDG, all of that is there, but those do not connect with our other dose monitoring systems. And so we always had to manually do our dose reporting for nukes. Now everything is in Dose and Care, and it's just all one place. And then it has skin dose mapping and stuff that we did not have in our other options. So this is a picture right here on the left of the home page when you launch it. And I'm going to drill down and show you some of the features on it. But you can see just real briefly, you can click on any one of these patient exams and it gives you all the specific details. It'll tell you green that everything's fine. It'll also give you kind of this thermometer right here. Even though it was a pass and everything was fine, it'll tell you with respect to what a normal exposure would be for this type of exam. It would tell you if it was the same, maybe a little hotter. If it's really hot, you can kind of see these ones over here, these really red, that this exam, even though it wasn't, there's no red alert here, it was just hotter than normal. And so it's just a quick way for me to kind of drill down and go, oh, I want to go look at this. Why is this here? And I know you probably can't read this, but then it shows you all the different metrics. So here I've selected CT, so it's going to show me DLP, CTDI, Volx, SSD, all that stuff. But I could click on my X-ray, my nukes, my PET, my RF, or fluoroscopy and stuff like that. And so on the top right here, which was cut off when I did my screen capture, you can see the rest of it over here. You can click right here on this patient alert, and it just takes me straight to a list of all the alerts. Obviously, we can also get alerts back from just email and whatnot. And so I can dig into the studies by alert. Like I mentioned, you have your daily work list, so it shows you just what today's studies are. And then, of course, you can click on statistics and do all kinds of graphs and plots to figure things out. You can break it down by station. You can't really see it right here, but it says location. You can do it by different hospitals, different outpatient versus inpatient. However you want to label those, you can look at them all over. The nice thing is you can also export to Excel. I personally like to manually manipulate my data, so I really do like the ability to go in and out of Excel. So that's just kind of a brief overview. And I think I just said all of that. Yep, I just said all that. Now, and I already said all this. I guess I should have been pushing the button. I'm sorry, guys. So there's a gauge. Like I said, it shows you the gauges. It gives you thresholds at a glance. Okay, so if you were to click on any one of these, like patient-specific, if you click on the little patient icon, for whatever, that's their patient icon right here. That'll actually come in here, and you can see all the patient-specific information, weight, BMI, all that. It'll give you all the study descriptions and whatnot. And the nice part is then you can click this button right here, and that would then launch a screen that looks like this, and it'll give me all my organ dose calculations based on their patient demographics. It gives me the effective dose values. And I like what it does down here is it shows me all of this patient received all these other studies over time. In fact, it shows you all the different studies for that modality, but you can see here, well, you might not be able to read it, but these are actually PET images. I can't even read it. Here we go. There we go. So it actually gives you like, there you go, right there. So it'll give you actually like the exposure, so the radionuclide activity. So not only am I getting the CT doses and stuff down here, but you can see this patient also had some nuke studies at some point. There would normally be some dates and times and stuff that I just cut off when I took the image. So it shows you the totality of what the patient's receiving when you start to drill down to the actual patient stuff. Once again, this software actually gives me a sum, and I don't like that, but it does provide you some kind of way to look at the total amount of dose that's happening. All right, so once again, you don't have to pick dose and care. You can pick Radiometrics. You can pick any one of the options out there. You just need to make sure it's right for you. I hold no claims to it. I get no money from Dose and Care, so you can pick whatever you want. Now, the last thing I wanted to talk about is I wanted to give an example of how we use these softwares. And so one of the things, so I actually took some of this data down into Excel just so I could plot it and to show it differently. And so one of the things we had an issue with for several years was our brain doses were real high. And so yesterday we were going through all the TIE data, and we mentioned that one of the hospitals had CT doses for the brain, non-contrast and contrast that were just a little bit higher than the DRLs. Well, we were the same way a couple of years ago. And so I wanted to give you an example of how we adjusted that problem. So quick example, here's a snapshot of what's going on. We're a pediatric hospital, so we have multiple different age-based protocols. You can see the dots are just straight across because we used fixed MA. So irrespective of the time, we're basically using the same MA. And so for me, that's actually, when I just do a quick look, normally you could see this plot. This came from Radiometrics. Normally you could just see the plot right in Radiometrics. But like I said, I usually like taking it down to Excel and playing with it. And so when I come over here, I open up those wonderful papers that Dr. Canal wrote for us, and I can look at the DRL values as a function of age for pediatric brains. And I can come over here, and let's just focus on this green top line. That's our greater than 13 key. We have protocols, and one of them is over 13 years old, which is basically our teens and our adults. And so I can come over here, and my AD value is 46, so the achievable dose is 46 milligram, and the DRL is 55. And here I just simply threw those dashed lines on here. If you were to set a dose alert value based only on DRLs or achievable dose, you would never, at least at my hospital, you would never get a dose alert ever, period. You just don't see any of my data points above this AD or DRL. So one of the things you need to do is you need to set internal dose alerts. This is just a good way to have a quality assurance program to make sure things don't kind of go off and you don't catch it until something bad happens. So here you can see along this green line, this is our protocol for greater than 13 years old. It's basically always there. But you see all of these random dots just here and there. So every so often something happens and the dose is different. It's just not expected. And so you need to set a dose alert that is going to capture a certain percentage of these randomly weird events so that you have some way to start investigating them. So you can come in here and you can look at the mean. Well, that's 35, but that's because the vast majority of everything is just operating as it should be. And then, well, I already mentioned that, so we're going to set a threshold. So how do we set that threshold? Well, what we did is we went and we did statistics on this, and when you look at the confidence interval, we looked at the 99% confidence interval. So we only want to look at exams that exceed that 99% threshold. In other words, only 1%, we only look at the protocol, the exams that had a dose that's greater than 99% of the total population. And that's what this dashed line is right here, called dose alert. And so when we did that, it's basically looking at 3 standard deviations away from the average. And when we did that, just for an example, last year I had 7 alerts for this particular brain protocol. And then I was able to look at those to see what went wrong. And so I'm going to give you an example. On this one, this patient had a routine head CT and a CTA. So it had 2 exams, 1 accession number. And what happened was the system, it actually took both CTDIs and put them together. And so that's why it went from being a nominal 35 all the way up to whatever that is, 42, 43 milligray. So it was just one of those things that Radiometrics did to us at that time, where it simply just added or did that kind of average weighting, and it made the dose a lot higher. So it was a false alert. And so for us, we just chalked it up, saying, okay, that was the technologist didn't do anything wrong. The CT protocol was perfectly fine. The dose for the CTA and the dose for the brain protocol were fine. It's just the way that the dose monitoring software handled that one event in that one moment. So I mentioned to you, we historically have had relatively high brain protocols, kind of going back to the 2015, 2016 era. So how did we adjust that and get our doses down to this lower level, which is where we are now? From 2018 on, we've been consistently, let's see, 40, 50, about 40 something percent lower. So what we did is, you can kind of see this stepwise approach. If you go in and turn any one of your protocols down in dose by 40%, I can promise you one thing. Tanya's going to call you. And Tanya's going to say, I don't like this image. And so we have to do things in a kind of a stepwise approach. And so with the permission, we didn't do this, we didn't hide this, but with the permission of the neuroradiologist, we said everyone recognized that their brain doses were high, but they were so used to looking at images that looked that way, they couldn't take the shock to their system by dropping the dose 30 or 40%. So what we did is basically every 2 or 3 months, we reduced it by about 10%. And then we would operate it for 3 months or so, and we would then go back to the neuroradiologist, because this is a brain example, and we would ask them, how comfortable are you with this quality of image? Can you see what you need to see? Were there ever times where you really struggled to make your diagnosis? And they would almost always say, oh, we're perfectly comfortable with this dose setting. So then we would go turn it down another 10%. And we did that again. And we did that and we did that until we got to a point where they said, you know, we're okay with this dose. We can see what we need to see, but we feel a little bit uncomfortable with the fact that if we keep going, we're going to start missing things. So this is a very non-scientific way to approach it. There are completely different ways to calculate this, and we're actually going to talk about them tomorrow and on Friday. But this was a very simple way, just in a stepwise, methodical way. We just lowered our doses just a little bit at a time. And the radiologist really never noticed it until we actually hit about 30, 40%. Now, like I said at the beginning, if I immediately turned it down 30 or 40%, they would notice it and they would feel very uncomfortable about that. But by simply doing it little bit by little bit, they became comfortable or used to the change in image quality. Now, obviously, it was 35%, not 45%. So obviously you need to do this in conjunction, radiologists, physicists, technologists. Everyone has to work together as a team. And if you don't do that as a team, then, you obviously can't make the decision. The neuroradiologists are going to tell you if they can see what they need to see. The physicists and the technologists are going to be able to play with those numbers. Please, go ahead.
I want to make sure I point this out because as you can see on your graph, you are still within AD and DRL. It's just that you think that dose was high, but I want to point out that your dose was totally fine based on what you were looking at, greater than 13-year-old, which is considered an adult for head, and you were totally fine. So if it was a different hospital, all I'm trying to point out is they may have done nothing.
Oh, sure.
You guys are just ultra conservative because you're a pediatric hospital, but for an adult, even greater than 13-year-old, that dose is totally fine. So just want to make that point.
And it's actually worth pointing out, and I don't have the data, but what we've actually, this is kind of a U shape. We've actually brought the dose up. So this was before my time. So I actually didn't make those decisions. And when the radiologist came in, and when we were at this level, they initially said, we're comfortable with this, but then with time, I started getting more and more complaints. And I says, okay, you're not comfortable with this. And so we actually brought the dose back up. So ours looks like a U right now. But that's a good point, and thank you for clarifying that. And that's a great example of how DRLs can help. It just, if it's above the DRL, we should probably do something about it. If it's below the DRL, the question to ask is, do you have enough image quality? All right, and this is I say multiple alerts. If you're a pediatric hospital or if you're an adult hospital that have multiple size-based or age or weight-based protocols, a single dose alert is not going to help. So I'm only showing one for our 13 because it would have just been ugly on this graph, but I actually have dose alerts for each of my protocols. Because if I set this dose alert here, my little guys down here, my 0 to 6 month protocols, would never alert. I would never know that something happened. And look at this little craziness. There was a couple of months there where our zeros, something went weird with our scanner, and the doses started kind of going all over the place. Now, they weren't crazy high, but they just started going wacko. And so we wanted the alert system to tell us. And the alert system told us what was happening, and it took us about a month to figure it out, and we did, and it went right back to normal. So dose alerts are really, really good way to prevent a bad thing to happen long term. And so you have to make sure you set them at the appropriate levels. And so don't set them too high, because if you set them too high, what's going to happen is you're going to never see anything. And if you set the alert too low, then you're going to get so many alerts, at some point you're just going to start ignoring them. All right, so that's all I had. If there's any questions.
No, thank you so much. Thank you so much. Seems like you train our eyes to get used to with something, and then you change a little bit, and you cannot tell the difference, right? Yeah. Yes. Okay, so next speaker going to be Dr. Kalpana Kanel, who going to talk about the Dosewatch, right? Software. And after that, we can discuss for the whole things together.
All right, good afternoon. Thanks, Sam, for an excellent talk. So I'm going to come from a totally different perspective. I'm actually going to talk about, Sam did a great job of talking about what to look at. I'm going to do a little bit of that, but I'm going to then show you how we use Dosewatch for things besides CT as well, just so, when you buy a dose monitoring system, you're not just buying it for one modality. So my title was, how do we use our dose monitoring system for data analysis? So again, Sam pointed it out, and I wanted to also point out that there are tons of many, many different dose monitoring software, and they really are helpful in spite of all the issues with them. No one is perfect. No monitoring software is perfect, but they're really great at doing dose monitoring in an automated fashion. So our site, we use Dosewatch. We are not like Sam's hospital. We don't have that much money. We have one dose monitoring system. So we have had Dosewatch for more than 10 years. And it's still a very complicated software. I don't love it, but I don't hate it either because it still does a lot of things that I don't have to do manually. But I wanted to point out this resource. It's a really good resource. If you go to this website, actually, why don't I try to go to it? You can go in there, and what it's showing you, I do not have an active subscription. Okay, fine. But you can see here that it's showing you all the different companies that have dose monitoring software. And I think Sam had mentioned there are 18, but there's a heck lot more than 18. And you can just go in there and click on any one of them. I guess now they've made it you have to pay, so I can't do that. But here's a screenshot from an older, so you can go click on this and then look at what each software offers. It used to be free. They smartened up and now they're asking for money. But basically, a few years ago, I went and did a screenshot and actually tells you, does the system support diagnostic reference levels set locally by registries or by regulation? And this is, you want to make sure your software is giving you DRLs, right, for adults and peds. And so this was for another talk I was doing at RSNA, and the focus of the talk was DRL. So I was trying to point out that the software can actually tell you before you buy it whether it does that if you're doing your own research. So look for that when you're trying to buy software. So just to give you a little bit of idea how dose monitoring software has helped us at University of Washington, I'll give you a little bit of history. Before we bought Dosewatch about 10 years ago, it was ridiculous the way we did data collection and dose monitoring. We had a big collection of disparate databases to track doses. Pen and paper, of course, the easiest way to do it. Crystal reports, if for those who may know, they were like risk reports where you used to run and get some data. We also trained our technologists to put in risks on one of the screens, the fluoro time and the air kerma. And then we used to run a report to look at that. And then local review at each system, which was really annoying. So we had many different ways, big waste of time. The weakness of all of this was the response time and awareness, right? Nothing is real time because you're keeping track, but you're not looking at the data real time. Data fidelity misentry, so the technologist might put in gray instead of milligray. That's a big difference in numbers. Misalignment, assignment to patients. It's not really, this doesn't make sense. This patient had this case, but you're writing the data for something else. Again, mention mixing of dose units. And only incremental, no cumulative perspective at, when you're doing things manually, because again, to keep track of all that is very difficult. This is our system that we look at. We actually have Dosewatch in the University of Washington hospitals, but I also cover Seattle Children's Hospital, which has Infinite, which is a different dose management. And God, if I don't like Dosewatch, I hate Infinite. It's even worse than Dosewatch. I just do not like it. But it can show you the spread here. So all the reds are Dosewatch. So these are all our different locations. And we have one out in the islands. And then for Infinite, we have all the Seattle children's sites way up north and then near the University of Washington. So you can imagine if we did not have dose monitoring, how difficult this would be to do manually on a manual basis, on a daily basis. So this is the way our setup is. From the modality, it goes to, just like Sam mentioned, once an exam is completed from the scanner, the dose goes to PACS as well as to Dosewatch. And then that's where it's collected. Then we have an archive server, or what they call an enterprise data warehouse. And then what we decided to do, we said, you know what, Dosewatch does not give us kind of like a playground where you can just play with the data. Actually, what I saw this morning with Radiometrics was very impressive. You can actually do things. You can't do a lot of that in Dosewatch. So we actually connect all our Dosewatch data to come to Tableau, to a Tableau server, and then we can just pull it on our computer wherever we sit, and we can slice and dice the data the way we want. The key to keep in mind here is all these connections. If any of them break, then you have to troubleshoot. Why am I not seeing the dose as of this morning? Why is the dose 2 weeks ago? But this was our solution to looking at Dosewatch data and analyzing it the way we wanted by connecting it to a Tableau server. So what has Dosewatch done for us? Well, first of all, we have one data repository for all our modalities and all our scanners. Very helpful, as you saw, the big spread that we have of the different hospital systems. High rate of completeness and data fidelity. It's not perfect, but it still gives us everything in a more systematic manner, same dose units. It eliminates any human error in terms of recording data, which is great. Of course, you still have to connect each and every system. So every time you get a new system, you have to go through the process of connecting it to Dosewatch. Then you have to validate the data that comes into Dosewatch, right? What is being sent or what you're seeing on the scanner, is it what's showing up in the data monitoring system? So that takes a little bit of time. And then some global means of alerting to high dose exams. As Sam did a very good job of showing the dose alert for that one case, we can now set up CT alerts for all our doses. I'll also talk about other modalities. So for interventional radiology, we do peak skin dose calculations. Dosewatch has been a lifesaver for us in figuring that out. Also, right now this has gone away, but Joint Commission had this whole Sentinel event where we had to do root cause analysis over if the dose went over 15 gray, that's no longer an issue, but that's another thing Dosewatch helped us with. And cumulative effect, we don't use it, as Sam did a great job of explaining why it's useless. We do not want to use cumulative dose. One event has nothing to do with an event from last week or last year or for a patient, so that's totally useless. However, you have to, again, Sam did a great job of saying how you set up alert levels. You do not want to give fatigue to our technologists by every, 90% of our exams alerting. So you have to pick a threshold that balances that, okay, this is okay if it's a little high dose, but we just really want to catch the big outliers that are really far away from our actual average dose. You have to make a method of calculating the entrance skin dose for fluoroscopy procedures. I'll talk about that a little bit. Flagging is based only on air kerma in Dosewatch, not on skin dose. And of course, all your underlying assumptions that you're going with when you're going from air kerma to entrance skin dose for fluoroscopy. And access to all the data, right? We can see what Dosewatch has and then build our own analysis by connecting it to Tableau. So just a little bit of general advice along the same lines that Sam mentioned. You want to understand your system architecture. Are you modality-driven versus PACS-driven or some other system risk-driven? There are larger implications for bandwidth and successful transmission, depending on how you do it. For us, it goes from the scanner straight to PACS, and then from the scanner straight to dose monitoring systems. Yes, we can integrate. That means a lot of different things depending on who you're talking to. Garbage in, garbage out. Better source data yields, better Dosewatch data. There's more clean information. We have the same problem in Dosewatch. It will take our combo studies and we will get a CT brain and a CT perfusion together, and the dose will go over whatever the threshold is, and then it's actually 2 different exams. Some old equipment may require software upgrade, or it may be impossible to connect to Dosewatch. So you have to keep that in mind. And you have to understand the fee structure. So once you buy the dose monitoring system, that's not the end of the story. So the way GE works is you have subscription level licenses, and you have to pay for that annually. And then every time you buy a new unit, if you run out of licenses, you have to buy more licenses. They make their money with all that annual subscription, not really with selling the software. So you have to understand that as well. And then it gets complicated when you have more than one hospital system like we do, right? We have 5 different sites that we are connecting, and it becomes a real management issue with Dosewatch. For us, we had one person in our group, faculty member, who was covered 30% FTE just to manage Dosewatch, because it is a lot of work. It is a lot of work, and for us, physicists drive it. it has to be the physicist because we are the ones who understand the dose. You still work with IT, but you are the one driving and validating and all that fun stuff. So it's a real problem, and I, thank God, I'm not in charge of it. My colleague is in charge of it, but it can give you a lot of headaches. And then generate a nomenclature that makes sense. So as your scanners come online or you're retiring them, new scanners, you want to make sure you are naming it consistently so that when you look at your list of scanners on Dosewatch or Radiometrics, that makes sense. Everything looks nice and uniform and consistent, and you can keep track by looking at the nomenclature. Oh yeah, this is this scanner at this site. Very important to keep that in mind as well. Identify the primary functions that you want to use and ask detailed questions. Again, similar to what Sam said, setting your dose alerts is extremely important. What onboard statistics can your system generate? What alerts you want to set based on your protocol, series descriptor, etc. This is a real problem that we struggle with. I mean, even yesterday morning, I got an email from one of the technologists who's trying to justify alerts in Dosewatch. And, it sends you Dosewatch. You cannot turn off the monitoring, when the contrast is injected and you're just monitoring. We don't want to send an alert for that. But unfortunately, with Dosewatch, that is also goes and causes an alert. And then how do you upload these alerts as well onto your dose monitoring system? Again, for Dosewatch, it's painful. You have to do it manually. It's really difficult. So all of these things that afterwards become a big time sink you want to ask before you buy the system. Start with a clinical question and leverage whatever you can. So I'll talk a little bit about how we use Dosewatch at our sites. I know this is a CT-focused session, but I want to talk a little bit about where we use it for interventional radiology as well. And I won't show any data for the others, but we do use it. The most practical yield for us is CT and IR. We don't do a lot with RF and mammo because the dose is so low, but I can still go and look at mammo for, a full exam versus just left side or right side if I want to look at the dose. Tomosynthesis versus full field digital mammography. But we haven't done a lot with mammo. We really our whole focus has been CT and IR. For C-arms, we have it all connected, but it's not really great for tracking because it lacks procedure-specific info. Our C-arm procedures will say less than 30 minutes, like especially the ones in the OR, or greater than 30 minutes. It doesn't tell me what you're doing, so it's, again, a little useless. And that's why it really depends on garbage in, garbage out. What are you feeding to Dosewatch or Radiometrics is what you're going to get. So C-arms, we track the dose, but it's really useless in terms of more specificity for the procedures that are being used, the C-arms are being used for. Time inputs, physics, at least for our site, is the main driver. We rule Dosewatch. If anyone wants access to Dosewatch, actually, we are the ones who give it to them. Most of the processes, alerting, threshold management, forwarding to dose index registry, account management, they're all done by our team. Some portions could be distributed to IT, but we have realized that since we know the system really well and what it's being used for, it's just easier for us to manage it. We still have to work with IT when we have to do upgrades because they're more at a higher level, but most of it we do. The decisions made in Dosewatch for alerting affect clinical staff, so we have to, again, balance that. As Sam mentioned, not too many otherwise they get alert fatigue, but you want to have enough alerts to know if something's wrong with your protocols. So I'm going to show you some examples of how we use Dosewatch. This is for interventional radiology, and interventional radiology is pretty high-risk procedures, and there you're worrying not so much about the stochastic risk, you're worrying more about tissue reaction. So I don't really care about cancer risk, but I do care about causing skin injury. So we do want to monitor the peak skin dose to our patients. So we have been doing that for years, pre-Dosewatch as well. And this is a screenshot from Dosewatch for an interventional procedure. And it's really nice. It gives you a nice study overview. It tells you your median, your 25th percentile, 75th percentile for this particular study description. And then in this particular case, the white dot shows you, hey, you have a problem with this case. It's much higher than the other cases. It shows you the distribution over 12 months. Then this is DAP, this is air kerma, which is all I care about. total time of fluoroscopy, in seconds. This is DAP again, and again air karma, but really good as a snapshot to see how this procedure has been doing over time and why is the problem over here. So this is a study overview. If I click again, this is what Sam was mentioning about email alerts. So we get emails on anything that we have set up from Dosewatch. So this is an interventional radiology procedure. I have hidden, of course, the patient information, even though it looks like this is date, time, and device. Here is my air karma, and you can see here the levels per set was between 2 gray and 4.5 gray. And so this patient had a dose of 2.5 gray. So we have our alert set up, and then we investigate from the air karma, depending on which machine it is, whether the skin dose is going to be greater than 5 gray. Because universally across all our hospitals, we decided anything over 5 gray to the skin, we are going to do a follow-up on the patient. So this is fantastic. This is a starting point for us. Our monitoring system sends us an email, and then physics decides whether we need to investigate this further or not. In the past, pre-Dosewatch, you had to do all this manually, and you're also being very extra conservative in determining that. So if you go to the second tab, it gives you the details of the study, and you can see here is a 2.5 gray, but it also gives you what the peak skin dose, and I'll talk about that in a minute. Also tells you all the runs you had throughout that case. It gives you all the information you need to make your decision whether this is a patient that I need to follow. So here is the cumulative dose incidence map that Dosewatch gives us for our IR patients. So you can see the nice spread of the dose, and it tells you even though you used 2.5 gray, your worst air karma, so everything at one area of the skin was only a little less than 2 gray. So it's a little bit more granular and tells you don't really need to worry about this too much because the dose to one area of the skin was a lot lower. But this could very well have been higher, and then you need to worry about that. So this really helps us. The other great thing I want to point out is it also helps us figure out the dose in terms of the different planes you're using, frontal plane, lateral plane, or both to determine the dose to the patient's skin. It gives us a good idea of dose spread, which is very helpful. And then we, the physicists, apply conversion factors to this worst peak skin dose, air karma, to estimate the peak skin dose. And if it's greater than 5 gray, what do? We send an email to the attending with a report, and this is what it looks like. I don't expect you to read that, but basically what this shows is the date reported by my section. Here's all the information about the patient, reason for the exam, and we are telling the attending that, hey, in this case, your dose to the skin of that patient was greater than 5 gray from the frontal tube and about 2.8 gray from the lateral tube. And then we also send them some information from the literature as what kind of tissue reactions could be possible. Now, this doesn't mean that every patient is going to get that. It's only been seen in 1% of the population. But we inform them, and then we tell them, hey, please send us a response back within a month, letting us know that when you did a follow-up of the patient, did you see any skin reaction or not? So we have been doing this for 15 years, 20 years at our hospital, way before this was required or savvy as everyone does it now. And it's really helpful, not only to the radiologist who's doing the case that, I should follow up on this patient, but the Dosewatch is helping me determine which case I need to follow up, which is, I think, the most practical and most helpful thing from Dosewatch I've got is for interventional radiology. I think this is just fantastic. And then, of course, if you want to have Joint Commission comes to our hospital, they were there last week, and they have all these requirements where they want to know whether if you had an alert, did someone look at it and justify it? Okay, that's a Joint Commission requirement. So this Joint Commission triggered alert report can come out of Dosewatch, and I'm sure Radiometrics can do the same. And here's an example of that for CT. And everything that's in red is higher than our alert level. And then you can see here, there's a column that says justified. What that means is that the technologists log into Dosewatch, go and look at these high-dose cases and justify them. And we all came up with a code when working with our technologists. So DW01 might be, oh, now of course I don't remember what it is, but it could be large BMI, or 8CO6 could mean arms were down, or difficult procedure, or something like that. So we came up with some codes, and the technologists go and put that information. So here you can see there's one comment, this patient was scanned off center. Well, scanned off center with automatic tube current modulation on, the dose is going to be much higher. This must have been cell phone is what it was put here. So somehow the cell phone must have, I don't know what that means, but these are the comments from the technologist. So I would focus more on the codes, which would make more sense to me than the comments. But what I'm trying to say here is the technologists log in and they justify. So you can see for this one, they did not justify. So one case they missed, or whatever the reason might be. But when Joint Commission comes in, we just show them these scanned reports with the technologist comments that we have done a follow-up to see why the alerts were high. And this, we make the technologists do that because it makes more sense. They're the ones who scan the case and they know why the dose was higher. Sam mentioned earlier that you go to your hospital, maybe 2 weeks later, it tells you there's something disconnected in your network, and the exams were not going from the scanner to your dose monitoring system. So we came up with and don't ask me how we did this because I didn't do it. One of my colleagues did it, but this tells us for all our CT scanners, when was the last time an exam was sent to Dosewatch. So you can see all the distinct count of CT accession numbers. So if I see one that has, basically 0 over last few days, then I'm like, like this one, for example, 00000. Is something wrong? Are we not getting data from the scanner to Dosewatch? So that's what this gives us, a quick dashboard. And my team looks at this on a weekly basis to make sure everything is still sending data to Dosewatch. And I had mentioned earlier that we connect all our Dosewatch to Tableau. So here is an example of what our doses look like for one of our sites. You can see on the left, on the right here, very hard to see, but all our different hospitals, everything is selected just for demonstration, and whatever scanners are selected. And we were just, I think, having a little fun with the data here, but just to kind of see, you can slice and dice this data any way you want. You want to look at it with one scanner? Fine. You want to look at all scanners? You can do that, somewhat like what we were looking at Radometrics today. But this gives us the data for whatever protocol, chest, abdomen, pelvis, with IV, across all our sites. And the shaded area here is the achievable dose and the DRL from the ACR dose index registry. So we are not as bad. We are kind of similar to SAM, except in some cases we are higher. But we will not, if we are in the range, we will not try to reduce our dose more. We kind of are fine with that. But that's because we are not a pediatric hospital. We get very few peds at University of Washington. All our peds go to Seattle Children's. The other thing you can do with Dosewatch or Radometrics, it's really great for technologist education. This shows you the scout image, the AP, and the lat view, and all this great information in Dosewatch. It gives you the size-specific dose estimate. So until it starts showing up on CT scanners, you can go into your dose monitoring system and actually look it up, what it is. Or you can do a calculation if you're a physicist. So it tells you what the CTDI wall is, what the size-specific dose estimate is, but gives you other information. It tells you what phantom you use, your scan range, what your DLP is, what are the dimensions of the patient. And it gives you the water equivalent diameter as well. And remember when I talked about SSDE on the first day, you can do lat plus AP, lat only, AP only, water equivalent diameter, and what factor was used to go from CTDI wall to SSDE. This is all great information to have, especially if you are trying to figure out more about the dose to that particular patient. This shows you, again, a great way to educate your technologists is centering of patient. So this over here, the dark circle is patient, like the solid white circle is patient. patient contour is a dotted one, and then the phantom is another circle shown here. And it shows you the delta X and the delta Y, and that's pretty reasonable. It's only 4 millimeters and 2 millimeters off center, which is totally fine and acceptable. This just shows you how your dose is modulating. Another great way to explain concepts when you're teaching radiologists or technologists, and how it's going down the dose in the lung area and then going up as it's going through bone. Here's another case. The patient is much larger, SSDE, but what I want to show you here was the delta Y. It's like 19 millimeters now. So it's getting a little bit higher than the last one. And so, that how it affects your dose is also important. We don't use it, I'll be honest with you, it's there, but we don't necessarily use it on a regular basis unless something comes up. Unless there's something happened in a case, we can then go look in Dosewatch and say, oh yeah, they were off by, whatever centimeters, and you can do some education. So these are all kind of cool things that otherwise, manually to do this would be a real painful process, right? I would quit if I had to do this manually. So having Dosewatch or Radometrics, I'm sure Radometrics has the same thing, right, Sam? I don't have Radometrics, I don't know, but I would think they do as well. It's really, really helpful to educate your technologists and students and physicists too. Very, very helpful. And I don't think we need to go through more cases, but here's in a much larger patient as well, and probably showing you even worse. Here's 33 millimeters, even further away from the isocenter, and how that might impact your dose. The other great thing that Dosewatch does, which is similar to what's in Radometrics, is we use the Duke model. Duke University in America, they've written the algorithm, and it can calculate all your organ doses. And that's what this information here on the right shows you. Again, I don't expect you to read it, but it gives you an idea of the organ doses for maybe in general for this particular case. And then one thing Dosewatch did in their last, or maybe 3 versions before, is they put this new screen called clinical information. So you can here now put in whether the patient is pregnant. Yes. You can put more information. You can put the depth of the fetus, the week of the pregnancy, date of patient perimeter, and all this information. If you want to put more clinical information, you can. Was this an adverse event or not? And you can save it. And that way, then you can monitor all your pregnant patients. And once you do that, you say yes, you go to the next screen, it actually calculates the dose to the fetus. And that's, again, something similar to what Radometrics does as well. So here, for this case, the patient fetal dose was 12.43. But this screen will not show up unless I go and actually put yes for that case in Dosewatch. I don't know if it has to do with patient privacy or whatever, but it won't calculate that for every patient because it's useless to do that, right? You just want to go be specific, and this information, when you put it, I think the way it calculates is based on papers in the literature. I think Angel's paper in calculating the fetal dose based on depth and patient perimeter. So that's really nice, right? So when I have a radiologist come to me or an OBGYN physician, or family medicine saying, hey, my patient was in radiology, can you give me an estimate? I would not go and do a whole calculation using Monte Carlo just to give them that information. I can go to Dosewatch, put the necessary information, and it gives me. Now, if the data I get was close to 100 milligrade, then I will want to do an independent check to make sure that that's accurate, because now you're reaching the high-risk area, 100 to 150 milligrade. But this is really helpful for physicists because you just quickly go look, get an idea, and tell the radiologist. And it gives you all the information, so you're clear on your calculations. It's using the Angel paper, which Sam knows about. She's a physicist, and all the information you put in and what formula it's using to calculate the fetal dose. Really, really great. And so now, once you did that, it added to the organ dose, it added the information for the fetus as well in the Duke model in Dosewatch. Really good, helpful information. So in summary, all I was trying to give you was a little flavor of how you can use these dose monitoring systems, because all we have talked about is CT, but there is a lot more out there that you can use it for. So dose monitoring systems, they're useful, but they're challenging. You cannot just buy it, plug it in, and you're done. No, there's a lot of steps of validation, and physicists have to be absolutely involved. It's ideal if you would have an IT person dedicated to it too. We kind of share the IT person with the big IT, for everything else that we need IT for. But it's, again, challenging. But once you have it set up, it's very easy. You need to understand how the architecture, the setup, and what is being displayed. So for Dosewatch, it's great. Infinite, as I said, I don't really like Infinite so much. DoseM is their program. And what they used to do is to sum all their CTDI walls. You don't do that. You don't do that. So things like that, you need to have confidence in the data that's coming out and validate that before you can say, yeah, I can blindly trust my dose monitoring system. So we use Dosewatch for peak skin dose calculation. I showed you an example of the skin dose mapping. I showed you an example of SSDE, water equivalent diameter, isocentering, and fetal dose calculation. I did not show you this, but we have all our systems connected to Dosewatch. So radiology systems are connected, nuclear medicine is connected, and COMs, and all of those are connected too. But really, the most bang for the buck is with CT and IR. I do want to acknowledge my colleague who helped me gave me a lot of the slides, because he is in charge of Dosewatch, thankfully, in my team. I don't need to worry about it. He takes care of it. So that's all I have to say. Thank you.
Thank you so much for the excellent talk and give us the insight, detail on the software that you use. Yeah, I'm so grateful to have you guys here as a physicist to help with solving this problem, because I have no idea with those data and number and like a click this, click that, click those. Thank you so much for having a physicist with us. This is like some kind of the expertise that need to work together with like a radiologist and technologist.
Absolutely.
Yes, yes. Any questions from the audience, comments? Okay, we have the questions from the online. Do we have to track peak skin dose at 2 threshold levels, such as 3 gray and 5 gray?
Yeah, so the threshold level that you pick depends on you and your hospital. All hospitals are different. We picked 5 gray because the table that I showed earlier, it's beyond 5 grays when you start seeing irreversible skin effects. So we decided across cardiology, radiology, electrophysiology that we would pick 5 gray. But you could go to like a children's hospital, and there we do more like 2 gray because they're children. We want to just make sure, or even 1 gray if you want to be conservative. But yeah, you could pick whatever level you want, but really the irreversible tissue reactions happen after 5 gray. And so you do not want to have so many alerts that you're sending all these emails to the attendings. So again, it's a balance, just like CT alerts. How much do you want to bother your interventional radiologist, but at the same time, you want to make sure that if there is a skin reaction, you catch it. So that's why we picked 5 gray. And actually, I'm thinking we should go even higher, because I've heard some physicists and some hospitals pick 8 gray, because you don't really see reactions. And all the time I've done this, maybe seen it once. And again, if I get 5 gray and Sam gets 5 gray, you might see the skin reaction on me and not on him. It just depends on so many factors. So that level is decided on a local level, what you want. There's a very good publication, 168, NCRP, right? NCRP 168, that gives you the whole, like it's very detailed on how you can pick your thresholds, what reaction, what you should do, things like that, which is freely available, at least on the APM website, that you can look at. Hopefully that answered the question.
I think so, yeah.
What is your setup at 2 or 1?
5
as well? For peds as well?
We looked at the literature too. Ultimately, skin is skin, if it's a little kid or a big kid. The biggest thing that we saw is when we went back, and we originally had ours set a lot lower, and we were doing a whole lot of dose calculations because we wanted to be conservative because they were pediatric. But the reality is, no one ever saw anything. They always came back a month later, no effects. And we only ever saw one where some slight reddening happening, and they were at 5 or 6 gray. So we said, we're wasting our time doing this.
So
and we're
you have it set up just like your adults.
So right now, everything is 5 gray, and that's when we do the dose calculations. They come back for 30 days for their follow-up, and then we log it. But it's rare nowadays.
Yeah, maybe we need to change that. Our children's hospital, we have it at 2 gray.
Yeah, 2, yeah. I mean,
Just again to be conservative.
it's a textbook. That's the textbook level, and so.
Yeah.
Is it the same number for the head and body?
Yeah, skin is skin.
Same. Skin is
Like
skin.
for the whole body, same number.
Same number.
I mean, the only things that really affect it, there are some genetic predispositions to it. There are drug interactions. So it is very complicated, as Dr. Canal has mentioned. That's why for us as physicists, when we set a threshold, we calculate the number, we send that back to the doctor. But we we have a similar letter. We tell them you need to do a medical history on them, and usually they already know this because they know their patients. But we just remind them you need to look at X, Y, and Z, look for drug interactions and all this, because though we don't think there will be an effect, you need to understand that there really could be, based on their medical history.
I think that's good that you have the letter and send to
yeah.
the radiologist, and you have like the option for us or tell us what to do, because sometimes, okay, I see the number, what else? What should I do?
No. And similarly, even for switching modalities real quick, but even for fetal dose calculation, my letter has 2 pages behind it with information so that they can make an informed decision about that case. So I will say, the risk to the fetus compared to no risk, things like that. So our goal as physicists not only to calculate the number, but guide the radiologist or any physician to make the right decision
That is a
for the
good-
best
yeah.
care for their patient.
I like it. I like it.
Especially, at least in the U.S., all of this information now is accessible to the patient. So they can look at their images, they can see all these reports, and so if you just give a number, it might freak them out. Because they'll go to Google, and then they'll see something on Google that'll freak
High
them
number.
out.
What should I do?
Yeah, and so having that information is very good.
มีคำถามอะไรไหมคะ จากฟลอร์จากออนไลน์ Seem like we don't have any questions. I write a couple things. Oh, Sam, you show the slides that like when you try to reduce the radiation dose, right, on the CT head. And I think like when we have like the new technologies and things like when we do the survey for the DRL, the dose going to go down every cycle when we do a survey. So which mean like radiation, the threshold going to change every cycle, and which mean like our dose level and things going to go down, right?
It can, and we have seen that. We've demonstrated that with the UK data. We've even seen that in the US data, that when you set that DRL, as people slowly optimize, well, the next time you do your survey, well, lo and behold, everything's lower.
And with the new technology as well, right?
Yep. But there will come a point where you'll kind of average out. The UK hasn't kept going down, and the Europeans are very conservative. But there'll come a point where you're going to hit that level where image quality will be affected.
Okay.
And we're going to definitely talk about that more tomorrow and Friday. So initially, you might see some of your values go from like 60 maybe down a little lower, let's say for a head. But I don't think you'll ever just see it just go.
I see.
Yeah,
Okay.
at some point, you have to stop.
Cannot ask for more like low radiations. Yeah. So I think we are probably done for today. I don't have any more questions, and we don't have any questions from the audience. So we're gonna call it end for today, and tomorrow we will see you guys again at 8:30. So tomorrow going to be like about the imaging CT image quality metric and optimization rule for radiologists, physicists, and the technologists. It's gonna be a very interesting day. It's like a more practical things, right? So thank you so much, everyone, and we will see you tomorrow again at 8:30. Bye bye. Take care นะคะ สวัสดีค่ะ สวัสดีค่ะ